Howdy and welcome to the Plasma Universe. Aurora. The aurora, plural aurorae, auroras, is a bright glow observed in the night sky, usually in the polar zone. For this reason, some scientists call it polar aurora or aurora polaris. In northern latitudes, it is known as the aurora borealis, which is named after the Roman goddess of the dawn Aurora and the Greek name for north wind Boreas. Especially in Europe, it often appears as a reddish glow in the northern horizon, as if the sun were rising from an unusual direction. The Aurora Borealis is also called the Northern Lights, since it is only visible in the north sky from the northern hemisphere. The Aurora Borealis most often occurs from September to October, and from March to April. Its southern counterpart is Aurora australis, has similar properties. Australis is the Latin word for of the south. There is quite something to read. I just will make a quick introduction. I will leave a link below so you can read the rest for yourself. Auroral mechanism. Auroras are known to be caused by the collision of charged particles, e.g. electrons, found in the magnetosphere with atoms in the Earth's upper atmosphere at latitudes above 80 kilometers. These charged particles are typically energized to levels between 1000 and 15,000 electron volts, and as they collide with atoms of gases in the atmosphere, the atoms become energized. Shortly afterwards, the atoms emit their gained energy as light. See fluorescence. Light emitted by the aurora tends to be dominated by emissions from atomic oxygen, resulting in a greenish glow at a wavelength of 557.7 nanometers. And, especially at lower energy levels and higher altitudes, the dark red glow at 630 nanometer of wavelength. Both of these represent forbidden transitions of electrons of atomic oxygen that, in absence of newer collisions, persist for a long time and account for the slow brightening and fading of auroral rays. Many other colors, especially those emitted by atomic and molecular nitrogen, blue and purple respectively, can also be observed. These, however, vary much faster and reveal the true dynamic of nature auroras. As well as visible light, auroras emit infrared, NIR and IR, and ultraviolet UV rays, as well as X-rays, e.g. as observed by the polar spacecraft. While the visible light emissions of auroras can easily be seen on Earth, the UV and X-ray emissions are best seen from space, as the Earth's atmosphere tends to absorb and attenuate these emissions. So, some time ago, I watched, or actually, I just tried to listen to some of those, those videos which you can put on, and there's some frequency and there's some pictures, and you can just listen to sound, which is not music since there's no rhythm. And I didn't make it that far. I will put a link below. So I made a screenshot already at 3 minutes and 15 seconds. Let's have a look, and I will tell you what I saw and why I couldn't be relaxed anymore afterwards, because I was too excited. Now that's just... Wait. No. See that? I think that's really interesting. Let's go back and zoom in a bit. The action is here. There start to appear these kind of white balls, and they move to this direction, and there's all of a sudden a white glow, and afterwards there's this Whatever they are called, plasma filaments reaching downwards. Check it out. That's really nice that they always put this picture here if you start to scroll around. Here is one, and it is a vertical structure, the aurora. And they are wandering quite quickly. This reminds me in a way of ball lightning. Yeah, I think this is very interesting. There is some kind of sea pinching going on or whatever. Increase of energy. The sun increase of energy. One, two, three, four. Uh, so obviously, if you zoom in too close, it doesn't really scroll anymore. So now we have this plasma ball here. I just call it like that. It might be wrong. I don't know what a better name you could give this kind of thing. While, like, I don't have any research equipment or whatever. I just think this seems to be, it is plasma after all. But this white stuff might be really dense, really high intense plasma, highly charged particles. Might be even really hot. Hmm. So now, as this fades, check out the lower edge. It's still in a way smooth. Despite here on this side we can see this the vertical structure of auroras. And now check it out. As this fades off, there start to emerge these spikes underneath. And I don't know. I don't think it's over this mountain. Maybe it is. I don't know. It would be really cool if it would be. It would explain something. Mountain would make a connection. I don't know. I don't think it's under the mountain. So that's just if it would be over a mountain. But it might not be. Did I make myself clear enough? So actually you can see also like those vertical filamentary structures here all of a sudden moving to the sides as this glowing ball disappears. There's quite much movement going on. Probably like a soap bubble as it explodes, the energy which got captured in the bubble itself, which means it's not the inside, like the bubble itself, the layer, the bubble. As when it bursts, the energy will dissipate in whatever energy circuits there are. They are part of everything after that. That's why they just don't drop down. They go to all direction. If a soap bubble bursts, probably have noticed after it burst and you had those soap waters things in your eyes. But anyway, let's check it out. Yeah, that's really interesting. Yeah. Try to watch a relaxation video with these eyes. Oh man, it's really, really interesting. You will never be bored if you open your eyes. Promise. Thanks.